All right, welcome to Essential 2. Essential 2 says I can find the missing side length of a right triangle. Um, Remember we had the two essentials this week. This is the more important of the two. This is what we're really trying to get at, is this idea of finding missing side lengths of right triangles. Um, just remember everything we're going to be dealing with the rest of this week and next week are right triangles. They're not just any triangle. They have to be right triangles for everything we're dealing with to work. Okay, and what does it mean to be a right triangle? It just means that the triangles we're looking at um, have these right angles in them. Right? Remember, that's what this little square box means, that this is a right angle. And remember, a right angle means that it's 90 degrees. So these two sides of the triangle come together to make a 90-degree angle. Okay. Before we jump into this, real quickly, I just wanted to let you know there's going to be two videos just because it's going to get a little longer. So this is going to be just a concept video, just talking about what is the Pythagorean theorem. That's what we're going to be dealing with, and what are all the pieces. And then there's going to be another video where I go through a few examples. Okay, so this is just going to be concept of what does all of this mean. Okay. Um, Looking at the parts of a right triangle first. Okay, so again, we're going to be dealing with the Pythagorean theorem. However, before we can look at the theorem, we need to look at the parts of a right triangle. So in a right triangle, and we know this is a right triangle because it has this little marker that says that we do in fact have a 90-degree angle in it. In a right triangle, we have three sides, just like all triangles. But in right triangles, we call these sides we have very specific names for the sides. So the two sides that make the 90-degree angle, right, we call these two legs. So that's a leg and that's a leg, right? So if when we're dealing with the right triangles, or for this week and next week, what if we ever say the word leg, we're talking about one of the sides that make up the right angle. And then we have this third side, which is not a part of this 90-degree angle, right? One way you'll see it is some people will talk about this, the side opposite the 90, right? Because it's not a part of it, is what we call the hypotenuse. Now that's a really funny word, and I find that in general, students struggle with it a little bit. I'm not going to write it out completely. It's right over here, hypotenuse. Um, but we're going to be abbreviating it HYP for hypotenuse. Okay, so in a right triangle, there's three sides. Just like in any triangle, there's three sides. The two sides that make up the 90 are called legs, and the side opposite the 90 is called the hypotenuse. Just so you know, you do not have hypotenuses in any other triangle. It has to be a right triangle for there to be a hypotenuse. Okay, and then now that we know the parts of this right triangle, now we can start to look at the Pythagorean theorem. Okay, so before we jump into this, what is a theorem? A theorem in math is just something that's been proved to be absolutely true all the time. It doesn't matter what situation you're in, what's happening, this is a fact. This is true all the time. It's been proved multiple times. We know that it is mathematically a fact. Okay, so this one, the Pythagorean theorem, um, was discovered by this guy named Pythagoras. That's why it's called the Pythagorean theorem, because he put his name on it, right? And it deals with right triangles, right? That's the first part of the theorem. It says in a right triangle, right? Because remember, this only works in right triangles, okay? So in a right triangle, the sum of the legs squared equal the hypotenuse squared. And I know that it's kind of a lot to kind of wrap our heads around, especially just in words. So visually, what does that look like? It just means if you take one of the legs squared and add it to the other leg squared, right, it's going to be equal to or have the same value as if you took the hypotenuse and squared it, right? So in a right triangle, the sum of the legs squared, that just means if you take the leg and square it and you add it to the other leg that's been squared, right? We add these two squares together, it's going to be equal to that hypotenuse squared. Okay. Now, if you remember in the last essential, we were dealing with squares and areas of squares and side lengths of squares because that's what we're going to be dealing with, right? This little exponent up here saying squared just means we're dealing with a square. So if I come to one of these legs, it doesn't matter which one, they're right. Let's just come to this one. It's saying take this leg and square it. In other words, turn this leg into a square. That's not a great square, but close enough, right? Okay. So when we actually square it, right, what we're talking about is actually the area of the square, right? And remember the area is that filled in the inside part of this square. So in this case, since we're just calling this the leg, we know this is going to be the same value. Just for, remember, like in the last video, let's just put a number on here to help us think through here. So let's just say this leg was 8. If we squared it, or if we make this squared, we know squares have the same side length. So if this is 8, this one's 8, this is 8, that's 8, they're all 8, right? Because it's a square. And then to find the area, what I do is I just take this times this. In other words, since they're the same number, it's just 8 squared, right? So that's what it means over here when we say it's the leg squared. It's just this side length times this side length. So in this case, 8 times 8 would be 64. Okay, and then we're going to add that to the other leg squared. So again, so what we would do is we would take this. I'm running out of paper, so it's not quite a square, but close enough, right? And we would square this one. Again, we don't have a number, so we'll just put in a number here just because it kind of, I think, helps us see what's going on here. So if this is 8, it's a little shorter, so let's say it's 6, right? Again, this square then would have the same side lengths all the way around. So if the up and down is 6, then this one is 6, and this one is 6, and this one is 6. And then to find the area of this, we just take 6 times 6, or 6 squared, which is 36. Okay. So over here, when it talks about the leg squared, all it's literally telling us to do is to take whatever this number of this leg is and multiply it by itself or square it, right? And get this number. Okay. And what we know is if I take these two numbers and add them together, it's going to be equal to the hypotenuse squared. So in other words, if I take this hypotenuse, right, and that would be a square here, the inside of this square that comes off the hypotenuse is equal to these two legs added together. So in other words, if I just take these numbers, so that would be 36 plus 64, right? Which makes this whole thing 100. And we're going to be using this idea to figure out what the missing side lengths are. We're not going to go any further with this at this point. With the examples, I'll kind of finish it. But here's the big point. Here's what we need to see. When it says leg squared plus leg squared equals a hypotenuse squared, we're literally talking about squares that are built off of the sides of a triangle. Okay, and so remember the legs are the two parts that are made up, make up the 90-degree angle here. And the hypotenuse is the side opposite that 90, or the side that's not a part of the 90. And so if we put squares off of all three of these sides, this square plus this square is equal to this big square. Right? That's what we call the Pythagorean theorem. Okay. Just to see what does that actually look like, or kind of like this is an informal visual proof. I have this image here. Okay, I'm going to have a link to this on the website so you can come and play around with it and slide all these things around and see what happens. But this is just to show you that same idea. So remember what we have here is we have leg squared plus leg squared equals the hypotenuse squared. So what we're focusing in on is this yellow triangle. Okay, this yellow triangle is a 90-degree triangle because right here would be a 90, right in this corner, right? That's a 90-degree corner. So this is a right triangle, so we can apply the Pythagorean theorem. Okay, so since this leg and this leg make up this 90, they're the legs, and this side is not a part of the 90, this is the hypotenuse. Okay, so if I take these two squares that are built here, so here you can see if this is 4 units high, and this, to make this a square, it's 4 units wide, and over here this is 3 units wide and 3 units high. So I make these squares off of these corners, and what the Pythagorean theorem says is this square plus this square should equal this square, right? And so with this animation, we can actually slide to actually show that this is true. So as we slide this over, you're going to see those two squares actually do fill up the big purple square. So this one just flips over, right? And then we still have that gap, right? We still have this gap to fill in. And so if we keep coming along here, then we can just going to take all those pieces from the other square and just slide them on over. And if what I said is true, then this should fill in that gap perfectly. And you can see it does, right? And that'll always happen. It doesn't matter what size we have. So if we take this slider here, I can adjust the size of that triangle, right? So you can see this isn't the same anymore, but it's the same idea. If I slide this over, this square added or combined with this square should equal this big purple square. And you'll see it does, right? It's just that one flips over, and then that green one comes along and it's going to fill up that strip perfectly. And that will always happen every single time when we're dealing with right triangles. Okay, so that's all I have for you on this video. We're going to actually get into some examples on the next video. So that was just the idea here. The leg squared plus leg squared equals the hypotenuse squared, right? And then we're going to use this idea to actually find some missing side lengths in the next video.